Hello and welcome, I'm your Code Monkey. In this lecture, we're going to see a nice project that incorporates everything we've learned so far in this intermediate section. Although, actually, we've already covered a ton of stuff, and some of it wasn't necessary to get this demo built, which this is actually a great practical example of everything you're learning in this course. This course is all about C#, and C# has a ton of tools and features, but that does not mean you need to absolutely use everything all at once every time. The goal of all this is to use the things that help you achieve whatever goal you're trying to achieve. So let's see the demo. It's inside the Unity project, inside the lectures, and down here at the bottom we've got the intermediate project. So we have our game scene, let's open it. And here is the minigame running. So I've got a player object, I can move around by pressing the arrow keys or WASD. Then down here I've got an inventory with 3 slots, and there are some weapons and some items that I can pick up. There's also some enemies that are spawning and coming to me, so I can approach the weapon in order to pick it up, and I can click in order to start shooting and start taking down some enemies. So as I shoot, they take some damage, they get a health bar that goes down and updates, and eventually they die and they spawn a bunch of money. Then for the money, it's also something that I can pick up, so I can touch it and pick up all this money. I can see the UI is updating as I pick up some more money, and there's a bunch more items and objects. So for example, there's some bombs. Those bombs are also attackable, so I can attack them and I can destroy them. And then I've got the other weapons, so I'm using a pistol, and then I can pick up a shotgun, and down here on the inventory, yep, I picked it up. So now I can swap the shotgun and I can start shooting, and this one has a different shoot. So this one can now shoot multiple bullets at once. And again, I can pick up all this money. And then over there is also a nice little potion. I can pick it up, and again, that's also another item. It's a usable item. So I can use it, click to use it, and there you go. This goes into some kind of super mode where the player is now moving much faster. So I can move around really fast, and eventually it ends up. And I can select another different one. So let's go back to the pistol. Let's go into that one, speed it up. Back to the pistol, shoot that one, and so on. So yep, this is the demo with lots of stuff happening that involves a lot of the things that we've already learned about. There's player movement, there are all kinds of interactions, there's shooting, there's enemy, there's health, there's damage, there's an inventory, a whole bunch of items, abilities, and so on. So as you can see, lots of stuff. Now let's inspect this to see how it all works and how all the elements of C#, how all of them are being used. Although also, before we look at the code, let me make one quick note. Basically, how I built this project is not the absolute only way to do this. You could build this exact same project in a million different ways. So as we're going through it, if you think to yourself that you would build some element in a different way than I did, that does not mean that you're wrong. There's always many ways to achieve the same result, and the way that I built this demo is simply just one way out of the millions of possible ways to build it. So if you come up with a different way to implement the exact same elements, you can definitely be right as well. Okay, so here in the project files, we can see that this demo is quite a bit larger than the beginner demo. There's quite a few more files. That's due to the fact that it is larger than the beginner project, but also due to the fact that the code is much more well organized. There's plenty of small classes that do one thing and one thing only, as opposed to the beginner project where I tried to make it as compact as possible, which meant putting too much logic on the player class. Whereas over here, you can see how each file is actually pretty compact. You can see most of it pretty much just over here on the quick code preview. Most of these files are actually pretty small. So let's begin inspecting this, and let's actually begin with the most complex script of all, the player script. Let's do just a quick overview of this one before we see everything one by one. And right away, as soon as we open this, we can actually already see a bunch of things that we learned in this intermediate section. So right away, we can see a namespace. So all of the code for this project, all of it is inside this specific namespace. And one of the benefits that I talked about namespace is simply the fact of name collisions. And actually on this companion project, note how all the code for all of the various lectures and all the demos, all of it is inside this one project. And I do have a bunch of other demos that also have some kind of player class. But because over here I'm using a namespace, that makes it sure that this player class does not have a naming conflict with any of the other player classes. So that's the first thing, using namespaces. Then by the way, the mono behavior over here. Here we are seeing an instance of inheritance, and mono behavior is really just a base Unity class. Basically, if you want to attach any script as a component in Unity. So for example, over here, if I select the player object and I look in it, yep, it has the player script attached to it. So in order to attach a script onto a game object, it needs to inherit from that class. Then we can also see over here we have the singleton pattern. So we've got a public static player instance with a public get and a private set. And this one, the instance is being set over here on awake. This is a Unity specific function that is called whenever this script is initialized. So on awake, we are instantiating the instance onto this. Since this little demo is meant to be a single player game, it makes perfect sense that the player is a singleton, since there is only ever meant to be just one player. Next, we can also see usage of a bunch of constants. Again, constants are values that are never meant to be changed. So in this little demo, it makes perfect sense to use a constant for the base movement speed, for the damage amount, and for the super timer max. Then we can see a whole bunch of events. We're going to see these in detail a little bit. Then we've got a bunch of fields. And by the way, the serialized field here, this syntax is actually an attribute. This is something that I cover in detail in a lecture in the advanced section. Over here, this specific attribute, this is another Unity specific thing. It is just so I can expose these fields over here on the Unity Inspector without having to make these fields public. If I were to just make them private without this attribute, then it would not show up in the editor. So in order to do that and keep the code clean, keep the fields private, in order to do that, they need to mark that serialized field private. Okay, then we have a bunch more fields. Then we got some inventory logic. We're going to see this in a little bit. Then we've got the update. This is another Unity specific function. Basically, the code in here is going to run whenever the frame updates. So if the game is running at 60 frames per second, these functions are going to run 60 times per second. We've got a function here to handle the object rotation. So that's the logic for how over here the pistol is rotating to face wherever I'm aiming with the mouse. Then there's some code to handle the items. I'm going to cover the inventory in a little bit. Then some code to shoot. Then we've got some standard movement code. So just some basic ifs, calculating a certain move vector, and then just moving the transform alongside this move direction. The transform is basically the game object in Unity. Then we've got the super, and let's begin by inspecting in detail over here the collisions. Again, this is another Unity specific function. This one has to do with the Unity physics system. Basically over here for all the objects that can be picked up, like for example over here the money. The money object over here has a little collider. So this little box is a physics collider, and basically as the player goes inside of this collider, it is going to trigger that function. And over here, this function will be called with whatever object it collided with. So the first thing we do is try to get a component. Again, it's another Unity specific function. This one tries to get any component of a certain type that is attached to the same game object. So basically as the player collides with this money object, it is going to try to get some of these components. And specifically, it is looking for a component that implements the interface iGrabObject. So here we see an example of an interface. In this case, this is an interface that represents any kind of object that can be grabbed. So in this game, that's the money, that's the weapons, that's a potion, and so on. And the interface defines a bunch of functions which all objects that implement this interface must implement. So one of those is, of course, the money class. So this one, as you can see, it extends the MonoBehavior class. This is the base Unity class, so this can be used as a component. And then it implements the iGrabObject interface. Then for the logic over here, it's pretty simple. This is really just some movement logic. So over here with the weapon, if I shoot a zombie, yep, there you go, the money gets spawned and moves a little bit, just to have a nice little bit of visual polish. So as the enemy dies, it spawns some money and moves a little bit and then stops moving. So that's really this code in action. It moves the transform, then lowers the magnitude, which is how big is the movement direction vector. And if it is under a certain magnitude, then just disables the script, which means this update function will no longer be called. Then down here, it implements the functions for that interface. So we've got one to destroy this object, and then some related to inventory objects. Now in this case, money is not an inventory item. It cannot be placed in inventory. So over here for these functions just returns false and null. Before we see the inventory, let's actually see how the money is actually connected to the UI. So over here in the UI, we've got a little indicator to show how much money the player is holding. So going back on the player script here, on the onTriggerEnter, over here we try to get a component of that interface type. And basically if the player hits the money object, then this is going to be true. It is going to be able to get this grabObject component. And when it does, it is going to fire off this event. It is going to fire off with some custom event args and basically pass along the grabObject that was grabbed. So this event is defined up here. So just a basic event handler that has a custom event args for our grabObject. And over here, actually something also pretty interesting, which is how in the events, you can subscribe to the events from anywhere. Meaning you can actually subscribe from the class that actually fires off that event. So that's exactly what I'm doing here. So I subscribe to the onPlayerGrabObject event. And then over here, accessing the event args in order to get the grabObject, and doing some type checking in order to see if that grabObject is of type money. So this identifies what object I picked up, and if so, then it's going to increase the money amount. This is just a basic integer. And as it does, it also fires off another event on money amount changed. And the one that listens to that event is this little UI element. So over here in the hierarchy, if I go inside the canvas, I've got this player UI script. And yep, this one is pretty simple. So on start, which is a Unity function that gets called whenever this object is initialized, so right after the awake. So when that happens, it accesses the player static instance, again, the singleton, which is super easy to use, which in this case makes perfect sense because this is a single player game, there's only one player. So it uses that to easily access the player, and then simply subscribes to the event on money amount changed. And when that happens, it simply calls the function in order to update the text. So it just goes inside the player static instance, again, accessing the singleton, calling a function to get the money amount that the player is currently holding, and just passing that on into string in order to update the text. This right here is a great example of one of the main purposes of events. It allows you to keep your code decoupled, and specifically in games, it allows you to decouple your logic from your UI elements. Note how over here on the player class, this one has no direct connection to any UI class. It does not know and does not care if there is any UI listening to any kind of money amount or anything, meaning this player class is completely decoupled from this UI class which does display the money. So if I'm playing the game and I pick up some money, yep, the UI up there is indeed updating, it works great. However, if I go there and I disable the player UI game object, so this script is no longer running, but despite that, there are no errors because again, the player UI, that one depends on the logic class, but the logic class does not depend on the UI class. Meaning that the player can exist without or with any UI, it does not matter, it works either way. That is really one of the main powers of events. It is how it helps you make your code much more decoupled so things can exist without other things. Now let's look at how the inventory over here works. So this one also has a nice constant for our capacity. Then it has a bunch of events that get fired whenever some things happen to this inventory. In order to store the inventory items, it is stored simply on a list and then just keeps an integer for the selected index. So basically which item is currently being selected. Then we've got some basic functions. So when testing if we can add an item, so we're really just testing the inventory list against the capacity. Then we got a function to add an object. And over here we have an example of a custom exception. So basically if we try to add an object without first checking if we can add it, so if we try to add it but we can't, if so, then this is going to throw a custom exception of this type, inventory full exception. So the exception is defined down here. Pretty simple, doesn't even have any extra data. It's really just a type just to be identified exactly what exception it is. But assuming things go well, it simply adds the item onto the inventory and fires off an event to know that the item list is changed. And then just has some more functions in order to set the selected index, to get it, in order to get the entire inventory item list and get the selected item. So here we have a pretty basic inventory. It stores a list of things and exposes a bunch of functions that can do certain things so you can work with the inventory. Also again, note how in this inventory class there is no mention of any UI anywhere. Once again, that is because of the same thing. So this inventory class, this one handles the actual inventory logic. And then we have a separate UI class that listens to these events and then updates the UI. So over here we can see that. So inside the canvas, we've got the inventory UI. So that is this element down here. And on this script, we have a reference to the inventory. This is the one that is currently being held by the player. And then we have a list of all of the inventory slots. These are all of these individual slots. These are individual objects. And as such, they have a custom class in order to handle each individual one. So rather than putting the logic for each specific one inside of the main inventory UI class, rather than doing that, it is nicely separated. So there's one class that handles the entire inventory, another one that handles each individual slot. Then on this slot, this one is a pretty simple script. We just have a reference to an image and the select game object. So the image is the icon sprite and the select game object is this little green arrow in order to show which item is actually being selected. Then over here, the behavior for each slot is actually pretty simple. So we've got one to set the selected state. So this really just either enables or disables that select game object with the visual. Then we've got one to set the item sprite. Again, just setting the sprite for whatever object is placed in that item location. And then we have another one in order to set the click action. So over here we can see delegates in action. So we've got a simple action delegate for the click action. And we're simply just going inside the button and adding a click action. So an action that is triggered whenever we click on the button. And all of these functions, these are all handled by the other inventory UI class. So over here, this one, again, this one has a list of all the inventory slots. And on start, first we access the inventory and we subscribe to the two events that we need to. So one then the item list changes and one when the selected index changes. Then here we can see the click actions. We can see a use of lambda expressions. So instead of defining proper functions, we're really just using the inline lambda expression. This works great when it comes to button actions. So we're telling it, giving it a click action for the inventory slot on index 0. So the first slot telling it to select this index when we click on it, then doing the same thing for all the other slots. And then we have the functions listening to the various events. So when the item list changes, when that happens, we want to update the item list and update which one's selected. And on this one, same thing, just update the selected. And then for these, for updating the item list, first thing we do is cycle through the entire list. We set the selected state to false in order to deselect all of them. And we set the item sprite to null in order to disable the items. Then we cycle through the inventory item list that is inside the inventory. We go through each of those elements in order to set the slot to the corresponding item sprite. Basically, this populates all the buttons. And then for the update selected, this one is also pretty simple. So first we deselect all the buttons. Then we access the inventory to get the selected index and set that one to selected as just that one. So yep, here the inventory is empty. And as I pick up a pistol, yep, it sets a weapon and sets that. And if I click on one of these, I can swap which item is selected. Then if I shoot, I can use the pistol. I can pick up the shotgun, click the selected and use it, or pick up this one, click it and use it. So yep, that's the inventory with various slots. Let's also see just over here the inventory. This one has an item list and it's of this type, inventory item. This is another interface. Here we can see the usage of an enum in order to define the item type. So it can be a pistol, shotgun, or a potion. And then various functions. So one to get the item type, to get the sprite, and to use the item. So with this, let's look at the weapons. And first of all, in terms of structure, I decided to separate the logical items that go inside the inventory and the actual items that exist in the world. So for example, over here in the world, there's a pistol that the player can pick up. This one has a script of type pistol object. So there's that one, and then there's an actual pistol that contains the logic. So there's always these two. There's the potion object and the potion, shotgun object and the shotgun. Here for the pistol object, this is the one that implements iGrab object. So this is how the player can actually pick up the weapon. And this one, unlike the money, this one does return true because it does have an inventory item. And when calling the function to get it, it simply creates a new pistol. So this is the class that is meant to handle the logic for the actual pistol. As to when that runs, it's over here on the player when the player triggers an enter. So when it goes inside another collider, it checks if it has a grabbed object, which again, the pistol object does implement this interface. Then the pistol object can indeed have an inventory item. So then it checks if the inventory can add that item. If so, it adds it onto the inventory and goes into the grab object in order to grab the inventory item. So that is what is going to construct a brand new pistol. And over here is the pistol script. This one has a function to return the item type so that it knows, okay, this is a pistol. It has one to return the item sprite. And over here we see another instance of the singleton class. We've got the game assets. This is a class that I use in pretty much all of my games. It's just a super simple way to access any kind of assets. So here in the game, in the scene, I've got a game assets object, and inside it has this script. And then this script, I can drag any references that I want to reference anywhere in the code base. So this is another really useful use case for the singleton pattern. So anyway, so the pistol gets the sprite for the pistol, and then it has a function to use the item, which in turn is going to tell the player in order to shoot. Then the player shoot function, this one is pretty simple. It really just fires a raycast. This is kind of like a laser in the physics world in order to find other colliders. This is basically how it finds other things that it can shoot. And over here, again, note how I'm not looking specifically for an enemy or a bomb, but rather an eye-attackable interface. So this is how the player can actually shoot any kind of object, not just enemies, not just bombs. It can shoot anything that implements this interface. But before we get to that, let's actually go back into the player class. And over here, note the override on all of these. That is because the pistol, this one is actually extending a weapon base class. And this one, here it is. This one is an inventory item, so that is how it can be placed on the actual inventory. And this one is marked as abstract because we are never meant to construct just a base weapon, but rather the weapons that extend from this class. And everything is abstract, so this is all up to the extending classes to implement these functions. So the pistol over here implements these functions like this. And the other weapon is over here, the shotgun. Again, this one also extends the weapon. And this one does override with different things. So it returns a different item type, a different sprite. And over here we've got a bit of different logic. So the pistol just shoots once, whereas the shotgun shoots multiple times. So now we can go back here into the shooting code. So again, this one fires a raycast in order to find all of the physics objects that it hit. If it did manage to hit something. If so, then it's going to try to see if that something is an eye-attackable object. And if so, it is going to cause damage to that object. Here is the eye-attackable interface, really super simple, just has a damage function. So basically, in order to make something damageable by the player, all we need to do is implement this interface. So for example, here we have the bomb class. This one does implement the eye-attackable interface, and this one is another super simple class. It has the damage function down here for the interface, and simply passes that damage function along down to the health system. So the health system, this is a great example of composition over inheritance. Basically, the bomb is meant to have some kind of health, so it has a health system. But specifically, it has the health system in a field as opposed to having all of the health system code directly inside the bomb class. This way it makes this health system reusable, which it is indeed reusable, since the enemy also uses this health system. So let's inspect it. And over here, this is another pretty simple class, just has the basic functions for handling some kind of health. So it just has a health and a health amount max. Then as usual, it has events for whenever all kinds of things happen, so on health change or on dead. Then we've got the damage functions, counts down the health amount, and if under 0, fires off the undead, and either way fires off the on health change. So that is why over here the bomb, this one we can note on start, this one is listening to the health system on that event, and when that happens it is going to run this code, which is going to destroy the bomb and fire off this event. The class that listens to that event is over here the game manager, which again, this is another one of there exists only one, so this one is a singleton. And over here we can see that it is listening to the bomb on any dead event. And when that happens, basically just spawns a VFX prefab. Just does that and shakes the camera. So over here, if I pick up a weapon and I shoot a bomb and I destroy it, yep, there you go, it fires off some VFX and shakes the camera. Yep, there it is, that's the bomb. Also note how the bomb also has a health bar that updates. This is another UI element that again is being driven by events. So here in the scene, we can see the bomb. We can see the bomb has a canvas inside the health bar UI. And this one, note how this class, this health bar, this has nothing to do with any bomb or any enemy. This one simply works with a health system. It does not matter where that health system is attached. It could be the player, it could be a bomb, could be an enemy, could be a building, does not matter. This health bar works on any kind of health system. And the way it works is super simple, just listening to a bunch of events. And when it does, then just goes into the health system to get the health normalized and uses that in order to make the bar image fill amount. So another super simple, super short script. It does one thing and just one thing. And then our enemy class, again, this one also implements iattackable, so it can be damaged. It also has a health system, so again, it can be damaged. It also fires off an on any dead event. And note how just on this one, and the same thing is over here on the bomb, note how these are static events, meaning that they belong to the class itself and not any instance of that class. So that is why over here on the game manager, when listening to that event, it does not need a reference to every single bomb and every single enemy. It just listens to the static event, which is going to be fired from any instance of that class. So for example, when any enemy dies, when it does, it's going to run this code, which really this one just spawns the money. So spawns and sets it to go into a random position. Then back over here on the enemy class. So we've got the event, we've got the health system. Then on update, we have some super basic AI, literally just moving towards the player. And again, the player has a singleton, so it makes it super easy to access. And then just listens when the health system dies, and when that does, it just destroys this game object. So yep, this is another super simple class. And the last two scripts that we need to look into are the holding object visual and the weapon animator. So the holding object visual, this one is inside of the player game object. Here we have a holding object. So basically inside of this object, we place either the pistol game object or place the other game objects over here inside the prefabs. We've got one for a pistol, for a potion, for a shotgun. That is how over here, the weapon that I'm rotating, I can select different weapons and rotate that one. So this game object has that script attached. And this one really just has a reference to the inventory in order to know when the selected weapon changes. And when that happens, it really just updates this visual. That involves getting the selected inventory item, then doing a quick null check just to make sure there is an item selected, and checking for the item type. This one is going to be an enum, so over here doing a switch on that enum, and depending on that, spawning a different prefab. And finally, for each weapon, like for example over here the pistol, it has a weapon animator script. Here is that script, and right away we can see a constant for a string. Like I said, you should avoid using strings as identifiers at all costs, but sadly, actually the Unity animator system, this one requires using strings. So rather than using a string down here for the set trigger on the animator, instead of doing that, I define a constant up here, and then for the rest of the code, I only use this constant. That really helps limit the amount of strings, meaning the amount of potential problems that we have. So it has a constant, a bunch of fields, then we've got the animator. Once again, this one also works based on events. So it subscribes to the on-shoot event on the player. And then when that happens, simply just set the animator in order to shoot. It spawns the VFX prefab, the little dirt that gets thrown out whenever shooting, and then just spawns the bullet ray prefab. Finally on this one, since this element is being swapped out, meaning it's spawned and destroyed, we need to make sure to unsubscribe to the event, so we don't have, for example, a dead weapon animator still listening to the same event. So over here on the onDestroy, which is a Unity function that gets called whenever the game object is destroyed, whenever this happens, we are just unsubscribing to the event, so we don't get callbacks for an object that is destroyed. Put all that together, and here's the object. I've got the inventory, I can pick up a pistol, and I can shoot a bunch of zombies. When I shoot them, they drop some money, I can pick up that money. Then I can pick up different weapons, so for example, I can select now the shotgun, and now this one shoots many more bullets. I can shoot enemies, and I can also shoot some bombs, and boom, there you go, they all blow up. It's all really satisfying. Then I can also pick up a different potion, I can use it, and all of a sudden I'm moving much faster, and there you go, just like this. Alright, awesome! So this is our intermediate project. In this really nice project, we have incorporated almost everything we have learned so far. You can go ahead and inspect this project for yourself in your own time in order to see how all the concepts we have learned have been used in this project. Feel free to play around the code and modify some parts to see how it all works. If you make a mistake and you break something, you can always just re-download the companion project, so don't be afraid to experiment. As always, you'll learn by doing, so take some time to do just that. Maybe build upon this in some way, maybe see how you could add another weapon, or another grabbable object, or another enemy type. Hopefully with this video you understood how it's all structured, so with this, plus the knowledge you've gained through this entire course so far, with all that, it should mean you should be able to fully understand how all of this is working, how all of these systems are interconnected. If not, then go rewatch some lectures on some topics that you find tricky, or simply feel free to post a question in the comments and I'll do my best to clarify any doubts.